Subchapter 4.5.4 Internal heat gains. For this, the heat is gained within the conditioned space. The internal heat gain comes from the occupants' lighting and electrical and electronics equipment. It may contribute in the form of sensible heat and or latent heat. Therefore, the analysis is performed for both sensible and latent internal heat gain. For sensible internal heat gain from the occupants, the heat transfer rate can be determined by multiplying the number of people with the sensible heat factor as HF, where the number of occupants is based from the design space, and sensible heat factor can be obtained from Table 10 for the exact or nearest application and level of activity. For sensible internal heat gains for lighting, it can be obtained by multiplying the number of lighting units with the rated power in watt, the type factor, and the conversion from watt to BTU per hour. The type factor for lighting can be either incandescent or fluorescent light. For incandescent light, the type factor TF is 1, while TF for fluorescent light is 1.25. We can also determine the lighting sensible heat gain by using this equation. The average occupancy lighting, OL average, can be obtained from Table 1. NA is the space area. The internal heat gain for sensible is represented in section C. If the design room having any electric or electronic equipments, we may include in this section. Once all values have been determined, we can sum them up as total C. Now we can obtain the room sensible heat by adding the values obtained from the section A, B, and C. Next, we are going to calculate the 10% safety factor before we add this value to the room sensible heat to obtain the total room sensible heat.